Welcome. The topic of this research is re-entrant triangular auxetic structures type arrow, an application for lightweight wheels and round flat tires, made by Roberto Chavez. The topics are introduction, methodology, code, results, conclusions and recommendations. Well, the material properties are divided in general properties, mechanical, thermal and electric properties. In general properties we have two examples, density and Poisson's ratio. The Poisson's ratio we divided in positive ratio and negative ratio. The Auxetic materials are included in the negative ratio in the Poisson's ratio. Auxetic and non-auxetic materials exhibit different deformation mechanisms. For auxetic materials, the deformations occur the opposite way that it could happen in a non-auxetic material. The auxetic materials base form are the cellular units, and we divided in different types: the re-entrant type, the chiral type, and the rotating type, each one with its variations. The negative Poisson's ratio or auxetic materials are used to make lightweight wheels and road flat tires. These tires can be tailored and functionally designed for optimally meet the round flat requirements for military or commercial applications. The objective is to design an auxetic structure applicable for a round flat tire that can be compatible with a CTIS. An auxetic wheel is based on a line-defined axis of rotation and concentric rings of a re-entrant arrow-shaped unit cells surrounding the axis. The most external ring on the design needs to be arranged to ease the rolling terrain contact. As we can see in the figures, we have some examples. Well, the code. The code has to follow the next path. We have to create the unit cell. We generate the mirror of the unit cell. We have the rotations and displacement. We create an X and Y axis matrix to create a unitary cell matrix. We select the matrix as the boundary face. Then we create the connection to use Arduino. We created a program that simulates the mapping code from the Arduino programming to obtain the signal from the force sensor. Then we programmed a fuzzy controller that indicates the condition of simulation. We have normal condition, road bump condition, and speed reducer. And then we created a fuzzy controller to modify the color of the structure with an RGB palette. We have the results at 45 degrees in angle in the auxetic structure and 70 degrees. In the simulation conditions, we have the three results: a street or road bump condition. As you can see, the structure is more wide. In normal road condition, we have a variation of the angle that simulates when the car and the wheel are in normal contact with the ground. And with the speed reducer condition, we have an narrower structure, so it can absorb all the force that we can generate when we pass across the speed reducer. Well, in conclusion, we have, despite the long history of mechanics, auxetic materials and structures still have unanswered questions. The interesting properties of auxetic materials and structures make them potential candidates for various applications, in this case from round flat tires. CAD software like Rhinoceros allows researchers to simulate the auxetic structure and its behavior. The simulation is the first step of the development of a brand new manufactured auxetic structure. These are the references. Thank you.